sketch the graph of a function f that is continuous on 3 through 8. So let's make axis here, and we are just focused on -3 to 3, -3 through 8, somewhere 8, maybe this is 4. Okay, and continuous means the graph should not have any jumps here, -3 through 8. This is y, and passes through the origin, so it passes through here. It has the absolute minimum at 7, so maybe 7 somewhere here. Minimum means the lowest point on the graph. Okay, let's say this is the absolute minimum at 7, absolute maximum at -3. So -3 maximum, this is the absolute maximum. Local maximum at 3. So 1, 2, 3, 4 local max. So this local max should not be above this. Okay, this is the absolute max. So at 3 maybe something like this one, it's turning curve. So locally this is the maximum. And local minima at -1. So -1 is here, local minima, maybe just below like this one. We need to connect the graph, by the way. It should not be below this, because this at 7 we have the absolute minimum, and local minima at 7. Okay, at 7 we have local minima as well. So the graph goes up to 8, maybe like here 8, and we don't have any other information, so we can just connect this. So this is 3, local max, and passes through the origin. So come back here, and local minimum at -1, and you can just go all the way to up at -3. So this graph, okay, this graph satisfies all of these conditions. It's continuous from -3 through 8. The graph is everywhere on -3 through 8, and passes through the origin. Yep. Absolute minimum at 7. At 7, that's the lowest point. Absolute maximum at -3, that's the highest point. So we need to put dot here because the last point. Local maximum at 3. At 3, we got this local maximum. Okay, and local minimum at -1 and 7. Okay, so this might not be, should be smooth, not like that. So okay, let's move to the second. Sketch the graph of a function f that is not continuous at 4 but has a local maximum at 4. So we don't worry about anything else but 1, 2, 3, 4. Just that's the only place we need to worry about. Not continuous but has a local maximum. So at 4, not continuous means the graph could go to infinity like this one. Both go to positive infinity, or one can go to negative infinity. But then we don't have local maximum because they are going to infinity. So this is not the case. And we can have discontinuous, or not continuous means it's a jump. It's coming from here and here like this one. So at 4, we can come from left and come from right. And we have to have local maximum. So if we do this, okay, now we have this function discontinuous at 4. Local maximum means at this here, if we put dot there, this is the maximum locally here. So this is the graph. Okay, we don't know what happens outside. It can go back, but locally, if we just look nearby 4, this is the highest point. So local maximum and discontinuous. So here the circle. We can't have dots. So dot there, highest point, and circle here. And here is another. Sketch the graph of a function that is continuous on 1, 5. So 0, 1, 2, 3, 4, 5. So graph should be here, and it has the absolute maximum at 3. So here we got absolute maximum, so the highest point, but f is not differentiable. Okay, not differentiable. And we know that when a function is not continuous, then it's not differentiable. But the function is continuous. So it says the function is continuous but not differentiable. That happens when we have a corner point like this type of thing, or this. When we have this cusp or corner point, the function is continuous but not differentiable. So at 3, I can just make a corner point like this one. Look, this is continuous from 1 through 5. Okay, I went even further outside, which is not needed. I can just stop at 5. So continuous, but at 3 is a absolute maximum because this is the highest point. But since this is a corner point, the function is not differentiable. So this is the correct graph, just that. Final